In the 3rd century BC, the Greek astronomer and mathematician Eratosthenes was able to estimate the size of the Earth with surprising accuracy. Eratosthenes was the director of the Great Library of Alexandria in northern Egypt. In one of the papyrus scrolls in this library, he read an account from Siene in southern Egypt. It was observed that on June 21st, the longest day of the year, vertical objects cast no shadows. As the sun approached midday, the shadows from the temple columns grew shorter and shorter until they were entirely gone. In addition, the reflection of the sun could be seen in the water of a deep well. All this indicated that at that moment the sun was directly overhead. Eratosthenes tried to reproduce these results in Alexandria on June 21st and found that there vertical objects did cast shadows at noon. From this discrepancy, he concluded that the Earth must be curved. He first reasoned that the sun shone light on Siene and Alexandria at the same angle. Since the sun is so far away, only the light that is aimed directly at Earth will reach our relatively small planet. The specifically aimed light hits all of the Earth from essentially the same angle and can be considered parallel. Eratosthenes then imagined 2 columns of the same height, one at Alexandria and one at Siene. If at any moment neither column cast a shadow, the sun must be directly overhead both, hitting them at the same angle. Even if they cast shadows of equal length, the sun would be shining on the right angle, formed by the columns in the ground, from the same inclination, a scenario only possible on a flat Earth. However, this was not the case. For the parallel rays of sun to be hitting the columns at different angles, the surface of the Earth must be curved. Eratosthenes reasoned that the greater the difference in shadow length, the greater the curvature of the Earth. From the length of the shadow and the height of the column, Eratosthenes calculated that in Alexandria on June 21st, the sun was shining at an angle of 7 degrees. Using Euclid's geometry of parallel lines, he deduced that if the columns at Alexandria and Siene were continued underground, they would eventually meet at the exact center of the Earth at an angle of 7 degrees. Since the 2 cities were 7 degrees apart on the sphere of the Earth, the distance between them was about 1/50th the distance around the whole Earth. Eratosthenes hired a man to walk from Alexandria to Siene and count his steps. This measurement showed the distance to be approximately 800 kilometers. With 7 degrees around the Earth measuring 800 kilometers, Eratosthenes calculated that a full 360-degree circumnavigation of the Earth would measure approximately 40,000 kilometers. This measurement, which is only 800 kilometers less than the Earth's true circumference, was made